Hi, and thanks for tuning in again. I'm Alfredo, and today I want to share with you how to generate and self-sign an SSL certificate. This is useful if you're developing a web application that's going to handle confidential data that has to be encrypted in transit, such as credit card numbers, personally identifiable information, or anything of the sort. SSL is something which may be familiar enough to the average listener, but that I think that not a lot of people really dive into. So I want to share a little bit of a primer for the uninitiated. Basically, SSL or Secure Sockets Layer, it's a technology that enables you to communicate in an encrypted way over the wire. In such a manner that if I send confidential information like a credit card number and somebody listens somehow or taps into the communication somehow, since it is encrypted for everyone except the sender and the person that receives it through SSL, anybody in the middle will not be able to really make any sense of the data that they get. For them, practically, it would just be garbled data. So first, to enable SSL, you need to create something called a certificate, which you install in your web server of choice, be it Apache, Nginx, or whichever one of the many options available in the market. This SSL certificate has to be signed by a certificate authority or a CA. A CA is an organism that is registered and formal and all that good stuff, and who proves or who signs that you are who you claim to be. For example, if I'm google.com, I need to get a certificate from a CA that proves that I am google.com, and that is done through manual process. So it is a very lengthy, complex, and actually quite expensive process. There's alternatives in the market to get free signed certificates, such as Let's Encrypt. And those are great for some customers, or for example, if you're developing a web application, you just need something to test. But again, sometimes you don't want to commit to the full CA process before, because you just need something to develop with or something to test with locally, and this tutorial is what that's for. So, let's jump onto the computer to see more. You should be looking at my screen now, and this is a rough sketch of the CA process. This is what we're gonna do. We're gonna create a CSR, or a certificate signing request. This is done through OpenSSL on Linux, and there's also ports available for other platforms. This CSR commonly is sent to a CA who runs their manual process and signs the certificate with an X509 request. And that certificate is the certificate that I install on my web server and which my customers will get. So let's get started here. So first, let's take a look at what you get out of the box. Out of the box, what you see is this. You get HTTPS set up for you, but the certificate that you get was last modified in 2013. So this is most likely gonna be expired. Let's just start XAMPP, as I did on the bottom right hand corner here, and then if we access localhost, we get a website served to us, so it means life is good. But if you prepend HTTPS to that, it's gonna throw an error because the certificate that the web server is using is not valid. And you can get more info about this here. Do you notice that it says that it expired in November? So this should be a screen that most of us may have seen previously because of some kind of error with the system clock or something of the sort. So let's fix this then. Let's jump onto the terminal, and now I'm gonna use OpenSSL. if you run OpenSSL on your terminal and you get this, it means you're good to go. Otherwise, if you don't have it and you're running Linux, just do sudo apt install OpenSSL. Should be pretty simple, right? So continuing though. So once you have OpenSSL, the first thing to do is to generate an RSA key. RSA is the de facto standard for encryption on the modern internet. So we're gonna do OpenSSL genRSA -out server.key, and I'm gonna add 248. That is how long the encryption key should be. If you see this, life is good. See, it generated it for us. Then once you have the RSA key, then generate the CSR. OpenSSL rec -new -sha1 -no-deth -key, and point the key parameter to the server.key that we just created -out server.csr. I'm gonna name it, and these just make the request so it is valid for as much as possible. I'm just gonna type this because, again, remember, this is a certificate that I'm just gonna use locally for testing. Normally you need something that expires every so often so the CA can actually prove or give validity that you're still who you claim to be regularly, once every year or so. But for testing, I'm gonna do this, right? All right. Now, OpenSSL is gonna ask you for a few pieces of information. So the US, and well, you will enter anything that you need here, right? And then locality name SEA. Let's do DBA developers. All right. FQDN. That's the name of the URL that you're gonna expose your website with. So for that, XAMPP by default has example.com built into it, and you can change that in the settings. But I'm just gonna stick to the convention for now. Email address and optional company name example.com. So now that we have the CSR here, the next step is to send it to the CA, and then the CA signs it with an X509 request. In this case, there's no CA, so I'm gonna pretend to be the CA. Let's do it again. OpenSSL genRSA. For this, I'm gonna use AES 256 because normally you need a more private key to sign certificates. So AES 256 will allow me to set up passphrase and -out ca.key, and again point it to 248. All right, I'm gonna enter a passphrase here, which is secret for everyone. Now, next step, once we have the CA key, we're gonna do OpenSSL, and again rec -new -x509 CA. We're gonna point it to the -key ca.key, and we're gonna generate a ca.crt. Once we do that, I'm gonna decrypt my, and it's gonna ask me to enter information about me as a CA. So, all right, locality name is CA, and organization name. Let's enter another name to make it clear that it's a custom CA. Custom CA. All right. Common name. And just go with that. Okay. So now that we have a CA certificate, finally we need to take what the CSR that the client sent to us and the CA certificate and sign the CSR with the CA certificate. And you do that with OpenSSL X509, again, -rec -in, pointed to the CSR, -ca ca.crt, -ca key ca.key, -ca create serial. A CA, once it generates a certificate, once it gives its approval that whoever is requesting a certificate is who they claim to be, they will generate a serial number for them. And it is the responsibility of the CA to keep that information on the graph. So -CA create serial -out server.crt, and this is gonna be the good stuff. Alright, now we're gonna add the SHA-256 parameter and an X-file parameter. OpenSSL allows you to pass parameters through it through a configuration file. In my case, I named it bit3.ext, and my file looks like this. So, authority key identifier, such and such, such and such. The important part is here. I'm gonna point it to localhost. If you don't do this, the certificate, you will be able to use it locally, but it's still gonna show you that Google Chrome error, and that's what we're trying to avoid. So, create a file like that and pass it to OpenSSL here. And once you do that, if you see this, it means you're doing okay. See the key, that's the passphrase that I set for the key a bit ago, and that will generate the server.crt. So finally, let's do the following. Let's go back to the XAMPP folder, and under Apache you should have a conf folder. And here, let's take the 3 keys that we generated, the CSR, and place it here. Yes, server.crt, place it here. And the server.key, and place it here. And restart your web server. And once you do that, open up your good old web browser and browse to HTTPS localhost. So it's gonna say that it's an invalid certificate authority. Why is that? Because you need to set up at your operating system level, you need to set the CA certificate as a trusted CA certificate. How do you do that? You can use the certificate that you just created here, double click on it on Windows, and then click Install Certificate. Do it for the current user, and place it on the Trusted Root Certification Authorities. Next, and finish. Yes, tell Windows that you're gonna trust that one, then reload this. Once you refresh on localhost with HTTPS, now you should get this connection secure, because I added the CA certificate to the trusted store. If you click here, it's gonna show that the custom CA that I use is indeed valid, and now everything is good, life is great, and you can continue to develop that amazing app that you're working on. So I think this is everything for now. Thanks so much for watching as always. I would really appreciate it if you drop a comment below, remember to like and subscribe, and feel free to drop a line if there's any other technical subjects that you would rather have me tackle. For now though, thank you again for watching, and we'll be speaking again soon. Stay safe and see you later.